So from yesterday, what was or what is the number one rule of matrices? Okay? What's the number one rule of matrices? So much of a number one rule that it is in the definition of a matrix.
Also have like the same dimensions in order to perform.
That's only for adding and subtracting. Is that they have to have the same dimensions. Okay? That's not in the definition. What's the one rule that's in the definition? I said it a bunch of times yesterday. That it's going to come back, and it's going to come back, and it's going to come back, and it's going to come back.
Organizing to rows and columns.
Not too much the organizing part, just the rows and columns part. Okay? Matrices, everything that has to do with matrices has to do with rows by columns. Okay? Okay? Everything that has to do with matrices is rows by columns. Today, we are going to multiply matrices. Okay? And so what we're going to do is we're going to follow that rule. And that rule is we're going to take the rows of the first matrix and we are going to multiply it by the columns of the second matrix. That's how we do it. We take the rows of the first one because rows comes first. It's not columns by rows, it's rows by columns. So left to right, we take the rows of the left matrix times the columns of the second matrix, or the right matrix. And we can only do two at a time. Okay? Now, the kicker with matrix multiplication is that it is the only time in math when you are multiplying that the order that you multiply it in matters. Okay? The order matters as to how you're multiplying. Okay? In math, 2 times 7 is 14. 7 times 2 is 14. Okay? That's not disputed. Okay? However, in matrices, I can multiply these matrices together as is. But if I rewrote them in a different order, if I put the matrix, the 2 by 1 matrix 3, negative 2 first, I could not multiply them. Okay? Because the order matters. Okay? So let's dive in head first into matrix multiplication. Okay? So our first step in matrix multiplication, which is different than yesterday's scalar multiplication. Scalar multiplication, remember, is just distributing it in. Now we're actually taking a matrix times a matrix. Okay? So my first step, step number 1, is I've got to look at the dimensions. In the specific order that we are multiplying. Okay? I've got to look at it. So I take the dimensions of the left matrix. Let's say that that is a 3 by 2 matrix. And then I take the dimensions of the right matrix, and I write them. The dimensions of the left one on the left side, and I write the dimensions of the right one on the right side. And I compare them. This has to happen. These two numbers in there have to be the same. If they are not the same, you cannot multiply them with good math. Okay? You may think you can do it, you may try to do it, but it is not sound mathematics. Okay? So if those two middle numbers, the columns of the first of the left matrix and the rows of the right matrix, if they're not equal, you cannot multiply them together, and you're done, because it is not possible. Okay? Now, the nice thing about doing this first step is that the dimensions of your resultant matrix are then the outside numbers. So my resulting matrix is going to be a 3 by 1 matrix. Okay? The two middle numbers have to be the same. The two outside numbers give you the resulting dimension. Okay?
I'll get you. Let's keep it there.
Okay? What are the dimensions of the resulting matrix? So, first thing I look at, are these two numbers the same? Yes or no? Yes, they are the same. So then the outer two numbers give me the resulting dimensions. So the resulting dimension here is a 2 by 5 matrix. Everybody good on that? Oops, I lost it. Where did it go? There it comes. Can I multiply those two matrices together? Why not, Henry? These two numbers aren't the same, so this is not possible. If I reversed the order, if I said here, if I went with my 3 by 2 matrix first, and then I multiplied that by my 2 by 2 matrix, then those would work, and I would get a 3 by 2 matrix. Okay? However, that's not, you don't have to do that. Okay? So like if the way the problem is written, if you see it and it's not possible, you don't have to flip the order to get an answer. The answer is not possible. Okay? All right? So, let's do this. Step number 1, we got to find the dimensions to see if it works out or not. Okay? So what are the dimensions of this left matrix? This matrix right here, dimensions. 3 by 2, 3 rows, 2 columns. Right matrix, what are the dimensions? 2 by 1, 2 rows, 1 column. Can I multiply those two matrices together? Yes. And what is the result? Or what is the size, I should say, of the result? It's going to be a 3 by 1. So how I would go about this then is I would make myself a large 3 by 1 matrix with blanks for the elements. because now that tells me I've got to fill those 3 answer blanks, or those 3 element blanks. Okay? How we go about doing that is we use the address. Yesterday we talked about how each element has a specific address. Okay? Well, the element here in this particular, my resultant matrix, is row 1, column 1. Right? So I'm going to take the first row times the first column. Because I'm in row 1, column 1, I take the first row times the first column. So that becomes 5 times negative 2 and 3 times 3. Here's my 5, I take those 2 and then those 2 together, and I'm going to add those 2 together. I don't just take all the numbers and multiply. I take the corresponding parts. Okay? Sometimes I do a finger thing, okay, where I take this row, goes into here. So 5 goes to negative 2. 3 goes to 3. Okay? With me on that. All right. Then this is row 2, column 1 for that address. So I take row 2 times column 1. So that's negative 1 times negative 2 plus 2 times 3. This is row 3, column 1. So I take row 3 times column 1. Negative 4 times negative 2 plus 0 times 3. Now, I'm going to do some math. 5 times negative 2 is negative 10. 3 times 3 is 9. Negative 1 times negative 2 is 2. 2 times 3 is 6. Negative 4 times negative 2 is 8. 0 times 3 is 0. So my resulting matrix is negative 1. It's going to be a 3 by 1. We already knew that. Negative 1, 8, 8. Rows by columns. Rows of the left one times columns of the right one. Okay. What I'd like you to do now is I would like you to multiply those two matrices together. My result is going to be a 2 by 2 matrix. This is row 1, column 1. So I take row 1 times column 1. This is row 1, column 2. So I take row 1 times column 2. This is row 2, column 1. So I take my second row times my first column, 2 times 5 plus 1 times negative 1. And this is row 2, column 2. So I take row 2 times column 2. 2 times 0 plus 1 times 3. Oops. Do some math. So this is 20 plus 3. That's 0 minus 9. This is 10 minus 1. 0 plus 3. So this is the 2 by 2 matrix of 23, negative 9, 9, 3. Questions on that? Good?
Stretching, sorry.
That's right. I couldn't tell. I think she's stretching, but I'm not sure. Good on that? Questions on that? All right. Try it out. Result is a 3 by 2. So I take the first row times the first column, and that's going to be 5 times 2. I take the first row times the second column, that's going to be 5 times negative 4. I take the second row times the first column, second row times the second column, third row, first column, third row, second column. So that's going to give me, we can jump right into the answer because we don't have to do any adding. That's going to give me the 3 by 2 matrix of 10, negative 20, 12, negative 24, negative 4, and positive 8. Agree? practice makes perfect. Two by two, 3 by 2. Doable? Nope. So my answer is not possible. Okay. Dimensions don't match up. Like last night's homework in the book, sometimes they will give you a, a list of different matrices, and then we'll ask you to do different things with that. Okay? So what I'd like you to do now for the next, I'll give you probably 10 minutes to do this. Okay? Find me what A times B is and what B times A is. How long this takes us? So that's going to be 1 times 6 plus negative 3 times negative 5 plus 3 times 7. I have to move that over a little bit. Times negative 4 plus negative 3 times 2 plus 7 times 1. Negative 1 times 6 plus 2 times negative 5 plus 0 times 7. Wait, nope. Plus 0 times 3. Which means I should change this one too. Like that better. Okay? And then I need a red, and that's going to be negative 1 times negative 4. And then that's going to be 2 times 2 and 0 times 1. Scrolling down here a little bit more. So then we've got, so that's 6 plus 15 plus 21. Negative 4 minus 6 plus 7. Negative 6 minus 10 plus 0. 4 plus 4 plus 0. Scrolling down even more gives me a 2 by 2 matrix of 42, negative 3, negative 16, and 8. Agree with A times B. Yeah. B times A would be a 3 by 2 times a 2 by 3, which is going to give me a 3 by 3. Oops, I might scroll down just a little bit. How much more can I scroll down? Give me some more space. So now I got to go in reverse order. So now I got to think, so what I would do is I would just probably go like this. So that's going to be 6 times 1 plus negative 4 times negative 1. 6 times negative 3 plus negative 4 times 2. 6 times 7 plus negative 4 times 0. Negative 5 times 1 plus 2 times negative 1. Negative 5 times negative 3 plus 2 times 2. Negative 5 times 7 plus 2 times 0. Whoa! 3 times 1 plus 1 times negative 1. 3 times negative 3 plus 1 times 2. 3 times 7 plus 1 times 0. Love it. That gives me, so that's going to be 6 plus 4, negative 18 minus 8, 42 plus 0. Negative 5 minus 2, 15 plus 4, negative 35 plus 0, 3 minus 1, negative 9 plus 2, 21 plus 0. So BA is going to be a 3 by 3 matrix, 10, negative 26, and 42, negative 7, 19, negative 35, 2, negative 7, 21. Negative 26, 42, negative 7, 19, negative 35, 2, yep. Now, the point of this was not to just be straight up mean and make you do a big 3 by 3 multiplication. Sometimes it works out that way. It happens. Okay? The point was to show you again, to reinforce the fact that order matters in matrix multiplication. Okay? Because those two matrices not only are not even the same size, but they're nowhere near identical. Okay? So so order matters. So A times B is different than B times A in matrices. It's not numbers, but it is in matrices. Okay? Homework for the weekend. It looks like a lot, but the first couple of are just like finding dimensions and does it work out kind of a deal. Okay? And then this will be due on Monday. What's Monday? The 18th. President's Day. Yes. Okay. That's all I got for you then. So yes, Sam, there is some work done.